Okay, everybody, this is Mr. Sellers' class, and this is going to be the lab for density of solids and liquids, otherwise known as the density lab. So I'm going to collect some data so you can actually see how the data is collected in the lab, and then you can calculate your answers and do all the follow-up work, including the graph. So first part we're going to start with is part A, the regular solid. So the part A, the regular solid, is going to be measuring the density of an aluminum block and a wood block. So first thing we're asked to do is to record the length, width, and height of the block of wood. So I'm going to do that over here. So the width of this block of wood is 2.5 centimeters. I'm just going to say the length. Doesn't matter, because what you're going to see is that it's a cube, so they're always 2.5 on all sides. So that makes it easy, but I'm going to measure it just to confirm. .5, that's correct. Now I have the data here. You'll need to calculate the volume using this formula, velocity. Volume is equal to length times width times height. That'll give you the volume. So I'm going to find the mass of this thing in a minute. Right now we're going to find the volume of the aluminum block. 2.5, surprising. Also 2.5. And again, because they're cubes, they should be all the same size, and I'm just confirming that, and that is correct. They are 2.5 as well. So again, you'll need to calculate the volume of this using this formula, V equals L times W times H. So now I'm going to find the mass of these two objects using the triple beam balance. So I put the piece of wood on there, and I'm going to start using the hundreds writer as that's what you should always start with. Okay, 100 is too much, so I'm going to back that off. Now I'm going to jump to the tens writer. Okay, 10 is too much, so I'm going to back that off. Now I'm going to come to the singles. It's probably close to 10. It's starting to move. We're going to go with, that is close enough, 8.5. So 8.5 is the mass of the block of wood. So now that I have the mass, and once you calculate the volume, I'll be able to go to my density formula up here and calculate the density here. So now I'm going to take the block of wood off, and I'm going to find the mass of the aluminum block. Resetting the triple beam balance to 0. Now I'm going to go to the 100 mark. Okay, 100 is too much, so we'll back it off to 0. Has to fit in one of these little rider spots. Cannot go in between. Common mistake. Let's see. 50 is too much. All right, 40 is good. So now we can start going the 40s. It's 40 something. Getting there, getting close. Okay, that looks pretty daggum good. Now, 40 plus the 0 plus the 5.1, let's see, 5, 6, 7, 8. So 45.8 grams. 45.8 grams. So now that I have my volume data and my mass data, once you calculate the volume, you should be able to calculate the density of this fairly easily. And that's it for part A. Alright, so on to data part B, which is the regular solids in graduated cylinder. So for this part of the lab, we're going to calculate the mass of 4 different types of metals: iron, brass, copper, and aluminum. Well, because we're using the same aluminum block that we used from part A, I just transferred that data over here to 45.8 grams, which is the same thing we got from part A. So I really just need to find the mass of these 3 blocks. Once I find the mass of those, then I'll be using a graduated cylinder to find the volume. And I'll explain that when I get to that. Let's start with the iron block. 100, 200. Okay, so 200 is too much. So we'll back it off to 100. $40's too much. 30's not enough, so we're getting there. It's 130 something.
It's 20.
Oh, 120 something, sorry. Getting pretty close. We'll go with that. That's close enough for me. That's 127.4. So the mass of the iron block is 127.4 grams. All right. I'm going to reset it. Reset my triple beam balance and go with the brass block. 100, not enough. 200 is too much. 240 is too much. Or 140 is too much. 130 is not enough. So we need to add some ones to it. Getting close. I like it. Let's do that. 138.3. 138.3 grams. Okay. I'll reset my triple beam balance for my last metal, which is copper. 100's not enough. 200's too much. So I'm going to go back to the hundreds, start moving my tens. 150's too much. 140's not enough, so I need to add some ones to it. Get too much. That looks great. 146 even. 146 grams even. So now that I've found the masses of these blocks, now I'm going to calculate the volume of these 4 different blocks as well. And this time, instead of using the ruler, what we're going to use is a 500 milliliter graduated cylinder, which I've put some liquid in here up to 200 milliliters, and I've also put some food coloring in here so you can hopefully see, or possibly see better. But it is at the 200 mark currently. And I'll show you how this works. A little bit different method than using the ruler. So the first thing we're going to do is, because I have 200 in there now, I already have on the data sheet the volume before is 200 milliliters. So now I'm going to slide the block in here. Sliding it in easily to make sure that it doesn't splash out. Each mark on this is 5 milliliters. Not sure how good you can see that, but it's 5, 10, 15. So that is 215 milliliters. So my final volume, or my volume with the block, is 215 milliliters. Well, I don't need to know how much the water is. I just need to know how much the block made the water move up in the graduated cylinder. So I'm going to subtract this. 215 milliliters minus the 200 gives me a volume of 15 milliliters. So in this case, I can just write this number right over here. Translates directly over. All right, that's the iron block. Now I'm going to move on to the brass block. So I have to get this out. Brass block. Starting at 200, it goes 5, 10, 15 more. So again, it's 215 milliliters minus 200 is going to give me a 15 milliliter final volume. Next, we're going to move to the copper block. So again, 5, 10, 15, it is 215 again. I'm seeing a pattern. Hopefully you are as well. We're gonna test the aluminum just to make sure it's the same, but I've got a feeling it is. And evaluating the data starting at 200, it is 5, 10, 15 milliliters again. So 215 milliliters is my volume with the block. I subtract out the 200 one more time to leave a final volume of 15 milliliters, which is what I've recorded here. So now I have the volume of all these blocks and as well as the mass of all these blocks. So now I can calculate my density using the formula D is equal to M over V. So you'll need to calculate this. This data will be what you'll be graphing in the last part of the lab. So make sure you understand that. Okay, the last part of the lab is part C. We're going to be calculating the density of fresh water. So the first thing we have to do is we have to measure the mass of an empty beaker, because when we try to find the mass of water on a triple beam balance, it's obviously just going to run off. So we need a holding vessel. So I need to find what my holding vessel weighs so I can subtract that mass out every time, because I don't want to know what the density of water in a beaker is. I want to know what the density of just water is. So 100 is not enough. 120 is too much. We'll go with that. That looks great. That's 100 plus 10 plus 5 is equal to 115 grams. Because I'm using the same empty beaker for the entire section of the lab, I know that this data will translate all the way down. So I can just say it's 115 grams for every single time. So now I'm going to add 50 milliliters of water. Now for this, I'll use the smaller graduated cylinder as it's a lot more accurate at a smaller volume. So here I already have the water up to 50 milliliters. So now I'm going to pour this into my graduated cylinder. I'm sorry, into my beaker. And now I'm going to find the mass of the 50 milliliters of water. So I know that it's more than 115 because that's what the empty beaker was. So I want to see if I can just add some more tens here. Okay, 160 something, a little bit too much. Oh, maybe I was wrong. Maybe it wasn't too much. Well, we're getting there now. Beautiful. 164 grams. So now if you look at the data chart, it says mass of the beaker with water, 164 grams. Now I'm going to subtract out the mass of the beaker because I don't want to know what the beaker is. So the mass of only the water would be 49 grams. So now I'm going to add 50 more milliliters because I've got to calculate the mass of 100 milliliters, 150 milliliters, and 200 milliliters. So since I already have 50 milliliters of liquid in this beaker, I'm not going to take it out. I'll just leave it in there and add 50 more to get my 100. That's pretty good. So I'm going to dump this additional 50 in here. Now that'll be 100 milliliters because I had 50 before. Now I have 100 milliliters of water in there. So I'm going to drop that back to 0. Go to 200. Drop my ones back down. 200 is not enough. 210 is close. Beautiful. 200 and let's just say 13, because that's definitely still close enough. Yeah, beautiful. 213 grams. Now remember, I'm going to subtract out the mass of my empty beaker, which was 115. So 213 minus 115 is 98 grams. Okay. So now I'm going to find 50 more milliliters of water in the graduated cylinder. Smudging too much. Beautiful. That's 50. So now this will be 150 milliliters, because remember I had 50, then I added 50 more to make 100, and now I've got 150. Now the beaker will give you a rough estimate of this on the side, but beakers are not accurate for measurement, so that's why we use the graduated cylinder. Alright, so now I have 150 milliliters. I'm going to add some more mass to my triple beam balance and see if I can get this little guy to balance out. So that is 260. So it is going to be 260 something. Pretty close. Beautiful. 262 grams. So now I'm writing that here, 262 grams. So now I'm going to subtract out the mass of my empty beaker again. 262 minus 115 is equal to 147 grams. So now, the last time I'm going to do this will be 200. We'll make it 200 milliliters total in the beakers. Right now I have 150 in there. We'll add 50 more. Beautiful. So I got my 50 more. That's some good measuring. Right, so I'm assuming this is going to be over 300. So I'm going to reset all of this and go back to the 300s. And it is over 300. So it's probably close to 310. Yep. Pretty close. We're going to go with that. 300 plus 10 plus 1 is 311 grams. So again, I'm going to subtract out my 115 grams for my beaker. I'm calculating 196 grams for the mass of the 200 milliliters of water. Okay, so now I'm putting a star up here because I'm going to have to calculate the density. Remember, D is equal to M over V. And the mass that I'm going to use is this mass here, the one I put a star above, because the mass of only the water is what I'm looking for. The volume I've already been given because I calculated it with the graduated cylinder. So this is the mass, this will be the volume, and then you'll need to calculate the densities here. After you complete that section, down here to the analysis part, it says you'll need to make a bar graph of the different densities of the metals of part B. So label your x-axis type of metal, label your y-axis density in grams per milliliter. You can use different colors if you'd like to. Make sure you include a key if you do. Now remember, that's the part B where we drop the large cubes inside the graduated cylinder. You also have additionally a couple other analysis questions that you'll need to make sure you have answered. And when you answer these questions, have all your data calculated, and have your graph done, you'll be ready to come in and take the density lab quiz. All right, I hope you found that helpful, and I'll see you in class.